All right, everyone, ready to dive in. Today, we're tackling the command design pattern in C++Z. Whether you're prepping for that big tech interview or just love geeking out about code, this one's for you. We're dissecting a presentation. It's from October 14th, 2023, by Roberto Chariton Kaplan.
Ah, Roberto Sheraton Kaplan, a classic.
Right. It's part of a larger C++ course, Module 2 to be exact. And lucky for us, it breaks down the command pattern with some really clear explanations and C++ code examples.
Always helpful to have good examples.
Definitely. Now, to make sure we really get into the nitty-gritty, the why behind it all, we've got our expert here.
Happy to be here.
So the presentation jumps right in, talking about encapsulating a request as an object.
The heart of the command pattern.
Basically, instead of your code directly doing something, you wrap that action in an object. Sounds simple, but I'm guessing it gets more interesting.
Oh, absolutely. It's like this. Think about building a house. Instead of telling every single worker what to do at every step, you give them blueprints. Those blueprints, those are your command objects.
Okay, I like that analogy. I can see how that would keep things more organized. But how does that actually translate to making code more flexible, easier to maintain in the real world?
Imagine you're adding a new feature to your software. If you've used this pattern, the command pattern, you might just need to create a new command object, plug it in, and bam, new feature, ready to go.
Wow, so you don't have to mess with the core logic of how those commands are actually executed.
Exactly. Which means less risk of creating new bugs somewhere else.
So it's like future-proofing your code to a certain extent.
You got it. Now, the presentation also mentions this idea of parameterizing clients with different requests.
Okay, now you're just using big words. What does that even mean in plain English?
In simpler terms, it means you can change how your program behaves without having to rewrite a bunch of code.
Okay, I'm listening. Give me an example.
Let's say you're building a drawing app, right? You could have a draw shape command. Depending on what the user wants, you could use that same command to draw a circle, a square, a triangle, all sorts of shapes.
So one command, multiple actions, that's efficient.
Exactly.
And this probably ties into the whole undo or do thing we hear so much about with the command pattern.
You know it. Each command object can have an execute method to, well, do the thing, and an undo method to reverse it.
Elegant, right.
Makes implementing those undo or do features way cleaner.
I'm starting to see the light here.
I see what you did there.
But I always like a good example. And the presentation actually uses a classic one, controlling a light.
It's a classic for a reason. Easy to understand, but really powerful to illustrate the core concepts.
Exactly. So break it down for us. What are the key parts of the C++ code in this example?
All right, so you've got your command interface, right? This sets the rules, the contract, if you will, for all our commands, primarily the execute and undo methods.
Makes sense.
Then we have concrete command classes, things like lighten and light off. Each of these implements those execute and undo methods to, well, you guessed it, turn the light on or off.
Lighten turns the light on, light off turns it off. Got it.
And here's where the magic of decoupling comes in. We have the remote control class, our invoker, and this guy doesn't need to know how the light actually works. It just holds a command object and has a method to tell that object to execute, whatever that might mean for that particular command.
So it's like pressing a button on a remote. You don't care about the electronics inside. You just want it to change the channel.
Precisely. The remote control doesn't even care if it's dealing with a light, just that it has a command it can trigger.
That's where polymorphism comes in.
Bingo. The remote control can handle any object that implements that command interface. Lighten, light off, heck, even change channel if we were building a TV remote.
Mind blown. Okay, so we've got our commands, we've got our invoker, the remote control in this case. It feels like we're building a system here, not just individual actions.
Now you're getting it. And that actually leads us perfectly into some of the broader applications of this pattern. But we'll get into that after a quick break.
Building a system, that's a great way to put it. And it makes you realize how widely applicable this command pattern really is.
Oh, for sure. We're not just talking about flicking lights on and off here.
Right, it's bigger than that.
It's a way of thinking about how we represent actions, operations, you name it, in our code. And trust me, it pops up in a lot more places than you might think.
Well, speaking of popping up, the presentation mentions GUIs, graphical user interfaces. I was hoping we could dig into that a bit.
Excellent example. Every button you click, every menu item you select, those are all actions, right?
Yeah, when you put it that way.
And each one of those interactions can be thought of as a command object just waiting to be unleashed.
Okay, so instead of having code directly tied to that button doing a bunch of stuff,
You have it trigger a command. Much cleaner, much more elegant.
All right, so let's say we're using a text editor, right? Clicking save wouldn't directly save the file. It would, what, create a save document command?
You got it. That save document command, that's what would handle the actual saving process.
Makes the code cleaner, but what else? What are the benefits of doing it this way?
Think about it. If you wanted to change how saving works later on, maybe integrate cloud storage or something, you'd only need to change that one save document command. You wouldn't have to mess with the entire structure of your application.
Ah, so it makes it more adaptable down the line.
Exactly.
And what about undo? We take that for granted, but coding that up can't be easy. Does the command pattern help with that too?
Remember those undo methods we talked about? This is where they really shine. Hit undo,
Mm-hmm.
and your application can call the undo method on that last command,
Mm.
reverses the action, just like that.
So if I hit undo after saving, it would, what, revert to the previous version?
Exactly. That's the beauty of it.
It's like giving our code a memory, a rewind button.
I like the way you think.
Mm.
And it highlights something really important. The command pattern isn't just about making code that works. It's about making code that's well-structured, maintainable, adaptable.
Code that won't give you nightmares later on, right?
Right.
The slides also mention menus and toolbars as good places to use this pattern.
Absolutely. It's a natural fit. Each menu item is basically a command waiting to be triggered.
So to use the text editor example, you might have a resize image command or something similar.
Perfect example. The user chooses resize from the menu. It doesn't immediately resize anything.
Mhm.
It creates that resize image command object, maybe asks the user for the new size, and then tells that command to go ahead and execute.
So each command is like this self-contained unit of functionality.
Exactly.
And this modularity, is that what makes the code easier to manage?
Absolutely. It's not this tangled web of actions all over the place. It's organized, it's clear, it's easier to understand and work with.
It's like the Marie Kondo of coding, tidying up our code.
There you go. That's a good one. But you're right. That's what good design patterns do. They provide elegant solutions to common problems. They make our lives as developers easier and our code more robust, more scalable, all those good things.
It's amazing, right? We started with this simple idea: encapsulate a request as an object. And look where we are. It's like we've unlocked a whole new level of software design.
It really goes to show you the power of abstraction and good design principles. The command pattern lets us write code that's not just functional, it's elegant, it's maintainable. Code that can actually handle the ever-changing landscape of software development.
Code that can evolve.
Exactly.
It's pretty amazing when you think about it. We started with this idea of wrapping requests as objects, and now we're talking about robust software design. Who knew the command pattern could be so deep?
It really shows you how powerful good design patterns can be. It's not just about the code itself. It's about the whole process, thinking ahead, building for change, making systems that can actually handle whatever gets thrown at them.
And the best part is, it's not just theory. That C++ example with the lighten, the light off, the remote control, that really brought it all home for me.
Oh, absolutely. Having those concrete examples, that's what makes it click. It's one thing to understand the concept, but seeing it in action, even a simple example like that, makes all the difference.
It's like, aha, I can actually use this.
Exactly.
So we've covered a lot of ground. We talked about the structure, the benefits of the command pattern, how it's used in GI development.
And don't forget those real-world examples.
Right. But before we wrap things up, I've got a question for our listeners. Think about the apps you use every day. Where else do you think this pattern might be at play? What features, what functionalities might be using this elegant pattern behind the scenes? It's a little something to think about. And on that note, I think we've done our deep dive for today. Hopefully you've all learned a thing or two about the command pattern in C++ area. Until next time, keep coding, keep exploring, and most importantly, keep that curiosity alive.